Okay, Assalamualaikum and good day. So, welcome back, okay, to our lecture. So, this is again a recorded lecture. Okay, previously we have covered on the time operations, okay, where we actually learn about the time shifting, time inverse, and time scaling, okay. So I just want to do some recap before we proceed with these amplitude-based operations. So previously that we have learned, okay, for the time operations, inversion, scaling, and shifting, right? Okay. If the time operation, if we see there is negative in front of our t, okay, then the signal we experience time inverted signals. However, if we have positive, we don't have that time inversions, okay. And then for time operation scaling, we will see here, okay, AT, okay, and we only consider the magnitude, okay, we consider magnitude of A, okay, means modulus, so it's always positive because we have considered the negative or positive condition in time operation inversion here, okay. But in time operation scaling, we only observe the magnitude, okay, which is the modulus of our A. And of course, our A is real constant. So if your magnitude of A is greater than 1, means the time will be compressed. So it will be speed up. And if your modulus less than 1, your time will be expanded. Okay, so your signal will be slow. Okay, then you'll also learn about this time operation, which is shifting. So the signal will be either time delayed or time advanced. If it's time delayed, it will be shifted to the right, and if it's time advanced, it will be shifted to the left. Okay, so you can see here t minus t naught. Okay, so make sure just to make an individual bracket, as I suggest, so that you easily distinguish, and to make you you will tend to to make less mistake in this way. Okay, then I put the screenshot of my sketching last time. Okay, and then this is the three methods. Okay, the three methods for you to do the combination of time inverse, time scaling, time shiftings. Okay, you can see here is your method 1, see here is your method 2, and see method 3. I only teach method 3 because it is the safest, and you will tend to make less mistake with it, and you don't initially you don't have to consider the operation inverse, um, shifting and scaling. However, as in the other, in contrast with the other methods, method 2, for example, you need to know this condition, okay, while solving. So you can make mistakes. So I suggest method 3. But if you guys want to learn method 1 and method 2, is okay. I will not cover in this class, okay, for method 1 and 2. So then I do some demonstration on the screenshot, okay, and then I do some screenshots here. I attach to the slide. Okay, you will you get this slide later on, okay, with this additional sketching, a beautiful drawing, okay, of my beautiful drawing, okay. So please appreciate that arts, okay. Now we go to the next one, which is the amplitude, okay. Amplitude operation. So what does it mean by amplitude operation? So means that there is changes in your amplitude. Simple, okay. There is changes in your amplitude, like as in the time, which can be inverse, shift, or scaling. In the amplitude, you will have the same things happen to your signals, but it will be on your vertical axis. Okay, it will be on your vertical axis, which is your amplitude. Okay, so the changes will happen across the vertical axis. In contrast with time operation, the changes will occur along the horizontal axis, which is the time axis. So you will have some changes in anything, and it will be reflected on your horizontal axis. In time operation, okay, let's say you have inversions, time inversion. you will put a mirror, okay, in the middle. Your mirror will be a vertical mirror, vertical axis. Okay, your mirror will be the same position as your vertical axis. But in amplitude operation, if we have amplitude inversions, your mirror will be, you know, aligned or in parallel with your uh, horizontal axis time. So it's different. Okay, so one time inversion, your mirror will be vertical, and for amplitude inverse, your mirror will be horizontal. Okay, it's as simple as that. So that you can imagine what your signal will be look alike after your either your inverse in time or your inverse in amplitude. Okay. mm, where was I? Okay. Uh, okay. You see here, signal xt. Okay, signal xt experience both shifting. You see, both shifting and amplitude scaling. Okay, both shifting and amplitude scaling. Okay, if you see yt equals to ax plus b. Okay, if you see here in amplitude operation, purely in amplitude operation, you will see there is no changes inside this bracket. There is no changes inside this bracket. Mean there is no changes in your horizontal axis. There is no changes in time. Your time should be the same. Unless there is something happening inside the bracket, then there will be something changes to your in horizontal axis. But you see here, this is just t inside, so there is no changes to your time elements. Okay, there then, however, there is some additional coefficient added outside this xt, which is your a and is your b. So your signal will experience changes in amplitude. Okay, so if you see here, you see an a. Okay, so your signal will experience scaling. Scaling means it's either going to get bigger or going to get smaller or going to be the same in amplitude. Okay, what does it mean going to be the same? If your A is 1, then there is no changes. There is no changes in size. So just similar in size, okay? In amplitude, the size of the amplitude. If your A is, let's say, if your A is bigger than 1, for example, 2, okay? So your signal will be twice as big, okay? But if you have half, for example, A is 1 over 2, then your signal will be smaller, okay? And then this B is actually going to contribute to what we call is as amplitude shifting, okay? If your B is positive in value, your signal will be increased. Your signal will be moved upwards in positive. If you have negative B, then your signal will be shifted downwards, okay, negative. And then A here is only consider let's the value, the modulus, okay. If you have positive, there is, if you have like 1 or 2, 1x 2x 3x, for example, positive number, and then the main the direction, and then the it is positive in value, so your signal will have no inversion. But if you have, let's say, -1, -2, -3, so means that your signal will be inverted. Okay, will be inverted. However, it will be inverted in amplitude, but not in time. Okay, repeat again. Will be inverted based on amplitude, but not time. You see here, there is nothing changed to the t here. Okay. Of course, later on when you learn in later, I mean, when you solve later on, you can have difficult questions. So where you have you have changes in amplitude and you have changes in time. So that's why later on, okay, the important thing is you need to understand the basic operation first on the time inversion, time scaling, time what else? Time shifting, time inversion, and time scaling. Okay. Then you will learn about amplitude scaling, amplitude shifting, amplitude inversion. Once you learn these 6 operations, then if we have combination, it will be easier for you, hopefully. Okay, so you must master this basic operation first. Okay, so we see here, okay, we see these examples. Okay, 7 yt equals to negative 2xt plus 1. Okay, so exit full screen. Okay, let us make some demonstration first. Not this, sorry. So where's the pen? Oh, tak ada. Sekejap I'm going to use pen. Okay, here. Okay, so now, okay, the question, okay, the same, okay, just like in the previous example, we use the same signals, okay, the same signal. First, okay, again, I keep reminding, when I keep reminding means it is important, but I hopefully that you will don't do this mistake, okay, because it's important. If you label the graph wrongly, then you have reduced in marks, even though your signal shape is correct. Okay, so let me see the original the original signals. Okay, I draw first. Okay, so then here is 3. This is the original. Okay, this is the original. We use the same signals, okay, as in the previous example, to get you familiar. So if we keep on changing the signal, it will be keep changing signal, it may make you understand a bit slower. So here is t negative 2. Okay, t is negative 2. Sorry if it's not really clear. Then this is your what we call, this is your xt. Okay, so we put some barrier there. Okay, now question want us to actually do to actually obtain yt, which is equivalent to your negative 2 x t plus 1. Okay, so now we are trying to see what operation in amplitude involved, okay, in this question, in these equations. Okay, first you see there is 2 here. Okay, so what will be happen to your signal? Okay, what will happen to your signal is that your signal will get bigger. Okay, your signal will get bigger, will be bigger, then it will experience scaling. Okay, and then you have here the negative. What does it mean? Then your signal here will experience what we call as inversion. Okay, and then you have here 1. So your signal will also experience scale in shifting. Okay, shifting. All this happen outside the t bracket. So all this is actually amplitude operation. Okay, I hope so far so good. Okay, since this is recorded session, if you have problem in understanding this lecture, okay, feel free to contact me. Okay, or I will later on create a forum. If if I remember, I will create a forum, so that if any question related to the lectures, you can refer, you can ask there, and of course I will My purpose in using forum is that, you know, we may, let's say if you don't understand this issue, or let's say you have assignment or you have homework tutorial you did and you put into the forum at this particular time, for example January, for October for example, and then later on we will also have some lectures, another lecture, right, in additional lectures, additional exercise whatsoever. Then let's say in December, okay, you want to look back, you want to look back to the previous issues that you don't understand, to the previous tutorial or the previous discussion that we have in the lecture or outside the lecture or with your friend, because your friend also will posting there in the forum. So in December you can always check what happened in October, for example, regarding this lecture, regarding tutorial for this lecture. Okay, that's why the forum can be helpful, because if we discuss in WhatsApp, okay, if we discuss in WhatsApp, yes, you still can browse, but can you imagine if we have a lot, we're going to have more and more and more lectures. So can you imagine you're going to browse all over to the top, okay, just to get to where that you are trying to trying to guess where is the issues at which date. So I think it's not practical. So that's why I think forum is the most suitable one, so where we can continuously discuss, even though the exercise is actually meant for lecture in October for example, we can still continuously discuss until December, January and so on, and we still can look back. Okay, so that is the important of you, I mean, I think the biggest advantage, okay, uh using forum. Okay, so inshallah I will create this forum. You know, if I forget, okay, I hope the class leader, okay, for section 3 the class leader is Lokman, Adi Lokman. Section 4 the class leader is Chintong. And let's say in future if we have section leader later on, because this recorded session may be repeatably used, okay, so please remind me if I forget to create forum for the lecture or for the tutorial, okay, because there will be tutorial, inshallah I try to make one, okay, if we do, if I don't have in my collection tutorial for the lecture, okay, for the lecture, so that you can have some exercise, correct? Okay, so continue. Okay, so you can see your signal here will experience amplitude inversion, amplitude scaling and amplitude shifting. Okay, so first, okay, first you can let's say, okay, here procedure of signal operation. So you start first with time operation. You only choose one method, okay, you only choose one method, which is method 1, 2, 3, but I taught you guys method 3. Okay, you can use method 1 or 2, it's up to you, but I don't want you to get mixed up, confused. Okay, so I think it's better to stick to only one method, which is method 3. Okay, which I taught you in class. Okay, then after that, procedure of synchronization after that is follow with amplitude operation. So since that this example that I'm sketching just now is on the amplitude operation alone, so there is no step 1. Okay, there is no step 1. Let's say later on if we have general operation where we have also changes in the bracket in the time, you should do so you should solve uh, based on this order first, okay, which is you should do based on the time of operation first, and then you will do the next one, which is the amplitude operation. Because the sketch just now, the example just now is only amplitude operation, so that's why I skip number 1, okay, because there is number 1 is not involved. Okay, that's why I proceed with 2, and then here then follow with amplitude operation. First you will start with inverse amplitude, second you will follow with scale amplitude, and then you have shift in amplitude. So first, okay, first we will need to identify um, identify if any inverse amplitude is involved. You can see here, inverse is involved. Inverse is involved. Okay, so you make inverse first. Okay, okay. So what just now? In time operation, your mirror will be vertical. In amplitude operation, your mirror will be okay. Let me do like this. Okay, so you can see. Okay, so this is your mirror. Okay, at the same time, your mirror is also your axis, which is your time. Okay, imagine this is the mirror. Okay, for amplitude operation, your mirror is horizontal. So this is your YT. I have little space here, so I don't have, you should write it full. Okay, like this. Okay, should be here. Okay, so first you need to do some inverse in amplitude if it's applied. Okay, in this case it applies because you have negative there. So now here, okay, here you have 3 here, 3, so you will have a negative 3. Am I correct? Okay, then you have negative 1 here, you will have 1. Okay, just inverse in the value of the amplitude. Okay, then likewise in the time operation, there is no changes in amplitude. Okay, but now in amplitude operation, okay, there is no changes in time. Okay, so your time should be the same. Okay, here 1, 3, and negative 2. Okay, so now is experience inverse. Okay, first I use different colors so that you can easily see. So here 3 inverse to negative 3 here. Okay, then here if you see at time 1, so it will inverse to negative 3 here. Okay, and how about 3 inverse? There's nothing changes to amplitude because it's 0, right? 0 inverse will be 0 again here. And then you see negative 1, okay, inverse will be 1, so here. Okay, and then at negative 2, time of negative 2, your amplitude will be initially is negative 1, will be inverted to 1, so here. Okay, so connect the dots. Okay, whatever the dots or cross, whatever you describe that, as long as you make it correctly. Okay, so now this is your inverse. Okay, now we need to this is the first step, which is your inverse. Okay, I think later on when you make, please make uh, make more exercise so you'll be faster in solving and you will tend to make less mistake in solving the exercise. Okay, honestly I don't I have yet to read the lattice book, and I don't have the answer. Okay, but if I found exercise which is related to our lectures, okay, I will introduce that to be your tutorial, but there's no answer. Okay, there's no answer in such a way that there is no schematic answer. Okay, so if you ask me a question on the lattice book, I may not able to answer directly because I don't have the schematic answer. Means I cannot give you direct your answer correct or not. Means that I have to solve it, or we will do it together. Okay, to check whether your solution solving is correct or vice versa. Okay, now we have do the first step, which is inverse. Okay, now we consider the second step, which is scale. Okay, scale. Okay, scale from this. Okay, you see here, now we scale as twice as big. Twice as big means that because it is 2. Okay, so everything, the amplitude will be times by 2. Okay, the amplitude will be times by 2. So again, like I told you guys, there is no changes in time. So you should use the same time. Okay, because this exercise is only for amplitude operation. Okay, so the time is still the same. 1, 3, negative 2. Okay, so now let we see on negative 2, time at negative 2, your initial amplitude is 1. However, now it need to be times by 2. Okay, so 1 times by 2 is 2. Okay, So I use different color now. You see, I use many colors to make your life colorful. Okay. Not to make your life colorful, so that you easily distinguish. Otherwise, if you can you imagine if I use all black colors? Okay. Okay. So here time t negative 2. So amplitude is initially is 1 times by 2. Okay. And then at 0, okay, at 0 you have one value, amplitude 1 times by 2, so you have 2. Okay. And then you have here is negative 3, right? So negative 3 times negative 2, negative 3 times by 2 is 6. It's negative 6. Am I correct? Okay, so negative 6 here. So you have a cross here. Okay. And of course here is, okay, 0 times 2 is still 0. And then after that, from 1, okay, at time 1 here, your initial amplitude is negative 3. So negative 3 times 2, you still have negative 6. Okay. And then here, okay, if you see, it's 0, right? So 0 times 2, still 0. Okay. So now you have this, then you make a connection. Okay. So of course, because of my drawing is not to the scale, you cannot see. Okay. You cannot see it different in size, but you see, actually at operation 2 the signal get bigger already in amplitude. Okay. So of course you cannot make that distinguish in scale here because of my drawings. Okay. But it is actually now twice as big. Okay. Twice as big. Okay. So now we go to the third step, which is what we shift, if they involve any shifting. Okay. So here you see there is shifting here, which is 1, positive 1. So your signal will be move upwards. Okay. Again, there is no changes in your time, so it's still the same. Okay. See the same 1, 3, and negative 2. Okay, no changes. Make sure there is no changes in time. Okay. Now increase upwards. Okay, increase upwards by 1. Okay. So negative 2, at t negative 2, initially it is 0. Okay, initially it is 0. So 0 plus 1 because increased by 1. So let's say we use now what color you guys like? Okay. Okay, purple. Okay, purple is my favorite color, by the way. Is okay. So now here you have 2, right? Okay, 2 plus 1 is 3. So you have here is 3. Okay. Then at 0 is, at time 0, the amplitude is 2. 2 plus 1, 3. So you still have here the same. Okay. And then for time at 0, you have another amplitude, which is here is negative 6. So negative 6 plus 2 is what? Negative 6 plus 2 is negative 5. So you have value here at negative 5. So your cross is here. And then at t1, okay, at t1, at 1 second, the initial amplitude is negative 6 here. Negative 6 plus 1 is 5. So here, okay. And then 0, initially at t 3 second, t equals to 3, your initial amplitude is 0. Now 0 plus 1 is 1. Okay. So you can see this is, now you connect the cross. Okay, you can use dot whatsoever. I don't really care, even in your, when you answering later on. If we didn't specify, you can use cross whatsoever as long the answer is correct. Okay. You can see now. Okay. So this is your finalized finalized signals. Okay, you can see, you can compare with the you can compare this one, okay, with this one. You can see how much change it experience. Okay, it's experience inverse, scaling, shifting. Okay, so in this example, the signal experience all amplitude operations. Okay, and then next, addition and multiplication can be done on two or more continuous time signals. Okay, so you can have addition and multiplication. Of course, you need to master this basic operation first, which is time inversion in three aspects just now, which is time inversion, scaling, amplitude. And then in amplitude operation, amplitude scaling, amplitude operation, amplitude shifting, and amplitude inversion. Once you have mastered these six basic operations, then the next challenges is actually when you have addition and multiplication of signals. So in this aspect, it's quite direct. Direct is that you can just add later on. You can just direct have some addition and multiplication of signals. Okay. Uh, like yt is equal, for example, yt is equal to x1t. Okay, for example, when it's involved addition and multiplication of signals. Okay, it means that you can have okay, let me save this first. Okay, snipping 2. Okay. Okay, let me save this to our slide first. Where is our slide just now? Okay. Senior operation, addition. So, okay. Now, new pages. Okay, new pages. Addition of signal. No, no, not save. Sorry. I don't want to save this. New, don't save. Addition and multiplication of signals. Okay, you can have, for example, addition of signal. You can have y equals to x1. I'm sorry. Sorry. Sorry for that, for the error. Yt can be resulted from can be resulted from addition of two individual signals. Okay, for example, x1t plus x2t. This is what we call as addition of signals. Okay, or it can be a multiplication of signal where signal is multiplied. Okay, so this is addition. You can have more. Okay, of course, before you even think of doing this, you need to master the basic six operation. Okay, which is the time. The basic operation need to be mastered is the time operation and the amplitude operation, time inversion, time scaling, time shifting, and then amplitude inversion, amplitude scaling, amplitude shifting. So this is six operation that need to be mastered before you even think of doing addition and multiplication signal, which logically will be will be more challenging. Okay, is logically more challenging. Okay, I add this to my slides. Yeah. Okay. So with that, we finish our lecture. Okay. See you guys in the next lecture or in the next recorded section. Okay, we'll see. Have a nice day and stay safe. Okay. Assalamualaikum warahmatullahi wabarakatuh and have a good day.